So we're going to look at Exponent Basics. This is 8th grade level Exponent Basics. So first we're just going to review really fast what exponents are, because we know, but then we're going to add a little bit to it. So an exponent, we have in quotes, is often called a power. Exponent's the technical name. This is sort of like a nickname. And it is shorthand for repeated multiplication. So instead of writing 5 times 5 times 5 times 5 times 5, you can write 5 to the 5th. So on this one, for some reason this box isn't quite big enough. It has 3 squared. Before we do the answer, I'm going to talk about the pieces. So the 3 is called the base. That is the number that's being multiplied repeatedly. 2 is called the exponent. And then to work it out, we do the repeated multiplication. So 3 squared means 3 times 3. This is called expanded form. And then if you go all the way to the answer, you actually do 3 times 3, which is 9. We would say that we evaluated the answer. So if you see something like evaluate or evaluated, that means go all the way to the answer. If they say to write an expanded form or write repeated multiplication, they're looking for this. And there's a little bit of both, just making sure we understand. Question? Yep. Okay, so on our examples, on the first one, we're going to do both. We're going to do the expanded form, we're going to write out the repeated multiplication, and then we're going to evaluate the answers. So on 2 to the 4th, if I'm expanding that out, what am I going to write?
2 times 2 times 2.
Good. 2 times 2 times 2 times 2. And so this is my expanded form, or this is my repeated multiplication, and then I have to do it. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So now I evaluated the answer. That's what the answer looks like. Now what gets tricky with exponents is when you have negatives. And because we're at the 8th grade level, we have to understand with parentheses is going to be different than without parentheses, and it has to do with the expanded form. So if I have negative 2 in parentheses to the 4th, that means we're repeating the negative and the 2. This whole group is going to get multiplied 4 times. So I have negative 2, and they often use parentheses to show this, just to separate all the negatives. Negative 2 times negative 2 times negative 2 times negative 2. And your answer could be negative or positive depending on your power. So let's think about this. If I have negative 2 times negative 2, a negative times a negative is a positive, so that gives me positive 4. Then if I take positive 4 times negative 2,
that's negative 8.
Negative 8. And if I take negative 8 times negative 2, I get positive 16. So I evaluated this, so that comes out positive. So whether this comes out positive or negative is going to depend on whether you have an even or odd power on here. Now I want to do the problem that's right below it. Actually, we could do this next. If I have x times x times x times x times x,
X to the 5th.
is x to the 5th. And then this one does not have parentheses. What that means is the 2 is getting repeated, but the negative sign is not. This just means negative. There's one negative sign, and then 2 times 2 times 2 times 2. This one is guaranteed to come out negative because there's only one negative in the whole thing. So it's still 2's, but this one just comes out negative 16.
But if the exponent is odd on the parentheses one, then
It will come out negative, yes. And we're going to see that here in a little bit. Or maybe we won't. Maybe it's on the next page. But we'll look at it in just a little bit. So yes, if this were an odd number of negatives, this would come out negative. So we should put a note next to here that this will be positive if it's an even power and negative if it's an odd power. This one is always going to come out negative. And you can reason through it like we just did. You don't necessarily have to memorize those things, but they're things that you could look back to check later if you're like, okay, I think I did this right. Did I do this right? But the main difference that I want you to get is when they put parentheses around the number, it's different than down here. On your calculators, if you were putting in a power, which you should know how to do, if you put in parentheses, it's assuming you want that negative to repeat, and it will give you this. If you just put in negative 2 to the 4th, it's assuming you want this. So you have to be very intentional if you're using a calculator about how you type this in. And so this is where our brains are good. This is why we can't just use calculators for everything, because you have to understand it to even put it in the calculator right. Okay? So we're going to look at some special exponents. So anything to the first power is just itself. I think we've looked at that before. So x to the first power is just x. Anything raised to the first power stays the same, and you can just take off the power. And they're using x to just stand for any random number, but it also works if you actually use a variable. And then down here, 0 power is something we haven't looked at, but I'm going to show you a pattern for that in a little bit when we do negative powers. 0 powers come out as 1, because basically if you're multiplying something 0 times, whatever this is isn't going to matter. Anything raised to the 0 power is 1. And we'll look at the pattern in a second. I should have probably put this down there, but that's okay. We'll get to it. So we're going to go through first powers and 0 powers. So if I have 5 to the first power, my answer is just 5. If I have negative 3 to the first power, it's negative 3, just whatever was in those parentheses. And in this one, I would take 3 to the first power, which is 3, and then stick the negative in front, but it actually came out the same. Just showing you it doesn't really matter on first power, and that's because this is an odd power. So this, I'm only going to have one of them. I'm not actually multiplying by anything else. And then this one, there's just one of them with the one anyway. They both come out negative on that one. And then these, when they have a 0 power, we get 1. So 5 to the 0 power is 1. Negative 3 in parentheses, all of this is raised to the 0 power. That's 1. Now this one is tricky. So I'm actually going to write tricky above this one. Because 3 is getting raised to the 0 power, so that part comes out 1, but the negative is not included. It doesn't have parentheses. So that one comes out negative 1, because the negative is not included on that 0 power. Whoa. Okay, does everybody understand why that one's different than this one? Because this one, the whole thing is getting raised to the 0 power. It turned to 1. This one, just this part's going to turn to 1, but that negative is just sitting out there. It didn't get affected by the power at all, because it wasn't in the group that was 0 powered. I don't know. I tried to make that cool. It didn't work. All right. So now we're going to look at a pattern, and we're going to look at how negative powers work as well. We're going to look at why 0 powers are 1 and what negative powers mean. Not negative numbers raised to a power, but negative powers. So we're going to do 3 to the 3rd power. So 3 to the 3rd power would be 3 times 3 times 3. So if we go 3 times 3 is 9 times another 3 is how much? 9 times 3 is 27. Okay? And then 3 squared, I'm only going to have 2 3s. 3 times 3, and that's 9. And 3 to the 1st power is just going to be 1 3, so that's 3. If you were just looking at these numbers as a sequence, they gave you 27, 9, and 3. And they said, what's the pattern? What's the next number going to be? How would you figure out the pattern? It's 27 to 9 to 3. If you didn't have this part, what would you say the pattern was, going from this number to this number to this? What are you doing each time?
Down.
You're going down. Are we going down by subtraction? No. Division. So it's like dividing by 3, which does affect the power. So it's like dividing by 3, dividing by 3. So to go from here to here, it's like I divided by 3. To go from here to here, it's like I divided by 3. So if I do that again and take 3 divided by 3, that's why this one comes out 1. And they sort of explain it up here. All of these could have had a times 1 on the end, because that's the identity and it wouldn't change anything. And then you could follow that 1 down. But then we have to think about what's going to happen when I go to 3 to the negative 1 power. I'm going down 1. This does not make the number negative. It's just going to divide by 3 again. So a way to write 1 divided by 3 is 1 over 3, and we use a fraction. So we're not going to use this old school division sign, which we talked about last year actually is 2 numbers with a fraction bar. We're going to write it as a fraction. So 3 to the negative first power is 1/3. It's not anything negative, which confuses our brains. Because up here we had negative bases, and sometimes they come out negative. If you have a negative power, it actually means reciprocal. So just off here to the side really quick, let's talk about that. What if I had 5 to the negative 1? What would I get?
1/5.
Good. What if I had like 8 to the negative 1? 1/8. Good. So that's just giving you a couple more examples. You get reciprocals. And then I'm going to throw a really crazy one at you. What if I had 1/2 to the negative 1? It's already flipped over.
Would just be 1.
So look, think about these. This could be thought as 5 over 1. We flipped it over. This could be 8 over 1. We flipped it over. So if I have 1/2 and I flip 1/2 upside down,
2.
I would get 2 over 1, which is just 2. Aha! Crazy. And you can actually have other things. Like if I had 2/3 to the negative 1, it would actually just flip it over and make it 3/2. So that negative 1 gives you reciprocal.
Would you reduce it?
So this technically is an improper fraction, but they usually just leave it.
Okay.
You're not going to get anything that you can divide the top and the bottom. And so you just leave it like this. And it's okay. You don't have to write it as a mixed number, which is what I think you're asking. No.
Yeah.
Okay, so let's think about what's going to happen if I take 1/3. I'm already dividing by 3. And then I divide by 3 again. Basically what this is, it's like I have 1 over 3 times 3.
Oh, so it's like 1 over 9?
Which would be 1 over 9. Okay, so let's try a couple more of those. What if I had 5 to the negative 2 power? So if you think about what 5 squared is, 5 times 5 is 25. This is 1 over 5 times 5. It's just 1/25. Let's do one that the power is bigger than 2, though. Let's do 2 to the negative 3rd power. So let's think about what that would mean. That'd be 1 over 2 times 2 times 2.
1 to
So 2 times 2 is 4. 4 times 2 is 8. I'd get 1/8. Crazy.
So if it gets it like just okay, I get that.
And if you're wondering why the heck we need to know this, we're going to use it to simplify some things, especially in high school. This is getting you ready for those 4 years of high school starting next year. And we're going to have to be able to combine things together that have the same base with different powers. We're going to do a little bit of that this year, and then it's going to get real next year. And then all the way through your senior year. My seniors, we had to go back through and review this so they could do logarithms. So it becomes a big deal in high school that you know this, which is why we learn it now.